Ramon, do you want to start with a short?
Yeah, I'll just give you guys something fun since it's, it says I need screen sharing.
Yes.
Yeah, I'll just share with you guys. Rich and Alana, and then another colleague named Ian Pierce are working on the surface rupture from those two earthquakes from 2019, the Ridgecrest sequence. And I have just show a couple of slides. And so I went there to help for just 2 days, but I was there. And so I thought I'd just give you guys a quick field report. And so here's just where it was. So this picture on the left is all the active faults in sort of Eastern California. And you see this alignment between these earthquakes that occurred in the 1990s, the Landers and Hector Mine, and then up here in the north is the 1872 Owens Valley. So those events are part of what's well known as the Eastern California shear zone. And then in orange is where the Ridgecrest sequence occurred. And the first event was on this kind of northeast trending structure. It was a magnitude 6.4 left lateral earthquake. And then 2 days later, a 7.1 ruptured along this trend on this northwest trend. It was right lateral. And so Rich and Ian and Alana and many others responded immediately. They went out to the site, and here's up in the upper right, a really pretty view of the surface rupture from, I think this is LiDAR, but it could be photogrammetry. But you see the sort of nice view of discontinuous rupture zone and offset of the road. And then you see them in the field. You see Alana there. And so then I don't want to take too long, but down here on the lower sort of southeastern end of the 7.1 is one of the sites that the team was working on that I was at yesterday. And this just shows a sort of hillshade with kind of the location and a crude sense of where the fault is. And then here is Ian Pierce and Alana just proving that they're in the field and heading out to the site to do the work in the trench. And then here's a drone video. So if you look in the very bottom is the silver truck, and then out where that orange thing is the excavator. And so the fault goes right in front of the truck and then through the excavator. So let's just fly.
I'm not sure we're seeing what you're showing. Maybe we are. Okay, now it looks good. Okay.
Is it okay? Okay. Yeah. So I'm just flying northwest along the fault right now. And so you see that there's some pre-existing morphology, and you see these breaks that are kind of where my mouse is. That's the 7.1 surface rupture. But even from before that, you could tell like there's this dark chunk of rock right here relative to the lighter on the other side. And that juxtaposition didn't occur just in one earthquake. And so we're flying along. You can see Ian's digging. It's hard to reel him in with his machine. I'm flying the drone, and Alana and Rich are getting the trench cleaned up, ready to work. We'll fly back. So now we're flying. The rupture's a little bit on the right of this view at the bottom. It's a little bit hard to see. And now we're going to turn around in a second. But the rupture goes off into this little saddle where the road was. This view right here, what's important to recognize is this bench. This is something that's kind of new to me. It's a lake terrace. So 12 or 14,000 years ago, this area had a huge lake. And that was where the shoreline was. And it had kind of, the wind had pushed the waves and they sort of chewed in to make this notch. So that's an important constraint, because actually the material even looks like total desert, is mostly maybe lacustrine, what's being dug up. And then this orangey yellow tan material is a kind of a carbonate called a tufa, which accumulates in these saline lake systems on the floor. So that's that bench. So that would be something we want to watch for if we were mapping that we didn't call it a fault. So now we turn in around. I'm not the greatest drone pilot, but get ready to fly down, and I'll pause it as we approach. So we're flying in one, and you kind of see, let's just stop for a second. It's hard to see any fractures from the surface structure in the foreground, but it goes right through the trench. Right here. So this step is the ground rupture from the earthquake, and then it goes through the other one. So that's the kind of motivation of why to dig here, along with this sedimentary unit that might have a record of prior ruptures. So that's the kind of video, and then just two more pictures, I think. So here's just this view of the one trench, has these kind of laminated units that are probably, but they're still pebbly and sandy, so it's kind of probably representing sort of transgression and regression of the lakes, and then some kind of reworking in that shallow lacustrine environment, and then it's over topped by then these kind of sheet wash from this poorly organized post-lake fan material. And then this was the one exciting thing. It's kind of a crappy picture, but on the left where the scraper is the bedrock. And this is some of that lake material. We found some shells in here, so it's kind of evidence of reverse faulting. And what's exciting is that it means that piece of rock that was right there, that dark zone, is bedrock that's been pushed up, and so there's a little reverse sense of motion on the rupture in this area. So that was a kind of exciting. So now we're turned around looking the other direction than the drone picture, but this nose of ugly looking smashed bedrock would be part of that kind of uplifted zone. So anyway, there's the most recent earthquake, I think, goes right to the surface. It's a little bit hard to see, but there's probably a paleo event underneath there that we're trying to work out if there's like a little wedge of cobbles that fell off the nose of a fault scarp back in the day. So anyway, that's my story. I don't know if you guys have any quick questions. I don't want to take too much time, but I wanted to just share that since my enthusiasm for it was high.
Thank you, Ramon. We have maybe one or two pretty quick questions, but then, as Ramon said, we should move on.
Yeah, and just big kudos to Alana and Rich and Ian. That I want to make sure they get the credit. I was just a guest.
So I mean I've never seen these trenches before, but that was a pretty small rig to be digging the trenches. They don't go too deep on them, huh?
No. Well, normally you would have a bigger rig. You could even have a huge one like a track hoe. Or a regular sort of standard backhoe with 30-inch bucket. That thing was, that little sort of almost DIY in your backyard thing with an 18-inch bucket. But the trade-off was that it's super flexible. You kind of dig, do whatever you want, and couldn't go that deep. So then for safety, it was fine. But yeah, interesting trade-off. But there's plenty to access in those upper 1.5 meters that he was getting into.
Did they have to get permits to go and do that? Or is that just like, oh, I'm going to go dig a trench?
No, Ian had to spend a bunch of time kind of kissing up to the BLM. And then there is concern about animals, the desert tortoise, of course, and a couple others. Alana, she's now an expert in ecology of these guys, and they were to be aware of them and also avoid digging up too much vegetation. But they have a full-on permit. Yeah, exactly. Mojave ground squirrel is protected, and the tortoises, of course.
Do you think there's any opportunity to do some trenches further north if working with the Navy?
There are apparently some being done. So USGS, so sort of the more agency types have access to the naval base. So this is what's on top of all the science. This is important because it's the only group that's basically working not on the base, as far as I know. And you know, the biggest slip and kind of some really spectacular stuff is on the base, but this isn't too bad, and it fleshes out the story, because it could be that these southern parts of these faults don't always rupture with the northern parts, and so could be possible, probably a more complex chronology of paleo events. But it's tough working out there. This obviously, even though, I mean, I think the lacustrine environments will help with the chronology, and in a couple of different ways, but you know, it's pretty high relief, a lot of coarse material. It's not any real obvious radiocarbon datable material, so it's challenging. But I think it's really unusual to have the chance to trench a rupture and kind of see how the textures in the subsurface relate to the surface pattern.
All right, let's move on to the presentations. So we have about an hour of class left. So we have 5 people. So each person can give 10 to 12 minutes to make sure that we finish on time. So who would like to start? And today we'll hear from Lori, Alana, Rachel, Jenna, and Sean.
Could I go first so I can get back to it?
Wondering if you wanted to go. So yes, go for it.
Cool. Let me just share screen here. Sorry, it's not a PowerPoint because I didn't have a chance to make it. So I'm also doing the Bora Peak section, and I know that it took CJ not very long to finish, so I just kind of started with a little bit outside of the boundary area anyway. And so I just started with the really obvious faults that I could see, and then I started transitioning over to the geomorph mapping. And everything in yellow is going to change because I'd like to do older versus younger fans, but I was just like getting the shape of them down because I noticed that this fan had a little bit of an interesting shape over here, so I thought there might be a few faults. And then I noticed these like facets, the triangular faces on the front of this range, so I figured there's probably a buried fault under these steep fans. And then there was a really clear scarp over on this side, so I put that in first. And then there were a few benches up here back in the mountains that I labeled also. I haven't gotten a chance to do like a lot of work on it, but yeah, that was just my preliminary logging. And so there's that scarp underneath that you can see really clearly. So if you guys have any suggestions, happy to hear it.
One quick comment, Alana, is what is the coordinate system? Oh yeah, see how your coordinates are lat long for your horizontals? That's why the hillshade looks kind of really ugly.
Yeah.
Because it's you know, whenever you do the hillshades with the lat long horizontal, you have to deal with vertical exaggeration. So that's why it looks weird. You might, when you have time, project that thing into UTM and then make a better looking hillshade and illumination from multiple directions.
Yeah. Okay.
Or also, CJ and I discussed you can just put in a Z factor or an S factor. They're basically reciprocals of each other, telling QGIS that your horizontal and vertical units are different.
Okay.
Because I think you will be able to see quite a bit more once you do that. And I think also CJ had to change the color range in the hillshade to make it look normal, because it was at like 10 to the 308 or something.
Okay.
And then also there's a lot of aerial imagery, which is actually what this DM is made from, that is I think quite valuable. You'll be able to see quite a bit that you can't see in the hillshade,
Mhm.
and or it will help support your observations. So I would highly suggest that both of you use that data and somehow work together to get it. So it shouldn't take you that long to get it, and Ramona and I can help with the georeferencing.
Okay. Okay. Well, thanks, guys. And CJ, I'll shoot you an email about, is he on the call? I can't see. Yeah, I'll shoot you an email and we can talk about the aerial imagery.
All right, thank you, Alana.
Thank you. See you guys.
Good luck. Good job.
All right, who wants to go next?
I could go next if you want.
Great, go ahead.
Okay. Ugh. Let me share my screen. Share PowerPoint. Is that looking good? See it all right?
Yes, looks good.
Bueno.
Anybody there? Oh, okay. All right. Sounds good. So yeah, just to update, this is my area. It's about 350 square kilometers. It's very highly vegetated, as you can see here in New Zealand. Pretty cool stuff going on there, like what Joe was saying last meeting. Here's our data set that we got. Here's it processed. This is just a hillshade. Can't really, I mean, it's not zoomed in, but it looks okay zoomed in. There's kind of some areas that have some weird resolution issues, but so I made a couple of different, so that was the slope shade. These are hill shades, different hill shades, specifically coming from the northwest and then from the southeast. I think the one coming from the northwest is actually a little easier for what I'm doing so far, but I'm going to do some more to make sure I'm not missing some structures in other directions. Seeing as how that, I mean, you can already kind of see a little bit of the fault there. I also made a 3D model of the DTM, which is pretty useful and not too shabby. I plan on putting some aerial imagery over the top of this. It's kind of cool because you can take some, you know, slice up your topography, and it's just like doing a profile, but you can move it back and forth and draw lines and try and figure out what the faults are actually doing. So I mapped the drainages. I started on one computer. So pretty much I did it on two computers. So I've got blue was one computer, green was another computer. So I got to figure out how to combine my line work, I guess. So that'll be my next project. I still have a little bit more to fill in, but this area is a little more difficult because of the resolution issues I was talking about. But right here, I haven't put any of my faults in yet, but I have been kind of paying attention to where I think they probably are. This is pretty obvious right there, and it goes across quite a bit of the mapping area. This is the resolution issues that I was talking about. This is kind of zoomed in pretty far, but I did that just so you guys could see. So it's almost like, I think this is because the area was very like highly vegetated, and so they didn't get like good ground control on the points. So areas like this, I think I'm probably, I mean, I don't know if it's useful or not, but I was thinking about getting the actual Google Earth imagery in areas like this, so I could still at least identify maybe some of the drainages, because I mean, it's, I don't know. That's a question you guys can answer in the end if you think that's worth my time or not. I also was thinking about mapping some of these alluvial fans, but still I'm not sure if that's something I want to spend my time doing. There's a lot of artifacts that are, I don't know, pretty distracting, but it still could be worth my time because the artifacts are easy to identify. But yeah, that's my progress so far. So
Great, thank you. Any student comments to start?
or suggestions?
Or suggestions? Yes.
You already know how you're transferring your line work, because I did the same thing where I started my project on a different laptop and ended up using it on a different laptop, and I just kind of shaved my shape files and emailed them to myself and then uploaded them onto the new one, and it worked.
Okay, but did you put them in the same file? Did you like merge them or?
No, I made them the same color. So if
okay.
Hemsworth's like on the legend, I'll just delete one of them, but they'll have the same symbology.
Okay, cool. Maybe that's what I'll do.
You go back, Sean, to kind of the overview.
Yeah. And show like this guy here.
Yeah, that's fine. Yeah, so I think, I forgot who was, maybe it was Joe is also doing this, but I think everyone's eyes are drawn to the high relief. And so you guys did a good job on all that, drainage network. But to me, there's a lot of interesting and somewhat unusual looking topography in the areas you haven't really worked on yet.
Okay.
And so I would definitely move into that zone and work on it and look for, I mean, in a way it's good that you map the other sections, because then you can look for what doesn't look quite as consistent in terms of the drainage patterns. But I do agree with you that this one river, whatever this is probably, if nothing else, it's some interpretable terraces and things like that. So I would make sure to work on that. And like you said, in my opinion, some of these higher relief zones where you don't have great imagery, it's okay to go ahead and look in the images where you don't have good DEMs, but I think it's a higher priority to get out into that coastal plain.
Okay, cool. No, sounds good. And actually this area right here, I don't know if you can see my mouse or not, but this area was a little more complex. That's why I was moving more to the easier stuff first. And then especially down in here is where there's really not very good resolution. Like it's very pixelated, but.
Well, then use the air photos down there.
Yeah, that's okay. Cool.
So you were saying that it was a little bit more complex down there. You're gonna map the drainages.
Yeah. Yep.
I used the single band grade scale layer from the TIFF, and it helped a lot with doing drainages.
Say that again. You used the what?
The TIFF layer, the single band grayscale.
You mean the elevation data or the aerial photography?
The elevation data, and that helped a lot with mapping those drainages. I would kind of turn it on and then turn on the hill shade on and off, and they're pretty spot on.
All right, cool. Sounds good. Well, thanks, guys. Any other suggestions? No.
I enjoyed the outline of your channels.
Thank you.
All right, thanks, Sean. Who would like to go next?
I can go.
Great, Rachel.
So I have the 2004 Parkfield, California earthquake. And so I did a little like precursor search. It's just kind of off the San Andreas fault. And then this is the Google Earth imagery that CJ was so kind and georeferenced with you and Chelsea. And initially, like until this morning, I forgot that I didn't have like the mapping outline on there. So I kind of just did my mapping kind of in the central thing. And because it's long, I broke it up into kind of 4 sections. And so for the initial stuff, I focused on the northern half of it. And then my scaling is between 16,000 and 32, because if I go any closer, it seems to be a bit grainy and hard to identify the features. And I kind of just did this kind of like as my areas of interest as I was doing a precursory thing. And I try to just kind of map all the drainages first. And I'm having that, is it a drainage, is it a road thing going on? But I'm getting through it. And there's a lot of drainages in this one. But I found at least some kind of cut off drainages and they don't continue on the other side. And I found these along the same strike on the right side of this area, which is nice. But I think I want to use Google Earth to look at the elevation to see if there's any triangular facets in the area to kind of give a better indication if there's faulting or anything. And then this northern area where this ridge is, I will also want to use Google imagery on just not the images to see if this guy is a slope or anything. And then I was also curious about this cut in the ridge and whether that is a result of erosion or if that is like another cross-cutting fault that can kind of offset it. Just wasn't sure. And I wondered if anyone had an idea.
I guess I would say, this, there's like 315 kilometers of motion through this area because you're looking at the plate boundary basically. So there's going to be a lot of evidence of deformation, but it at the same time is, interacting heavily with the surface processes. So I don't want to answer actually with the specific suggestion, but just, look very carefully at the drainage networks and look for where they start to deviate from what you might expect. This feature here in the Northwest called Middle Mountain. So it's a mountain in the middle of 2 other mountains. And so already the topography is kind of weird with drainages off the ranges, but then parallel to them when you're in the intervening valleys. So just, this is a rich place, but it has a lot going on. Also, there's a lot of landsliding that you'll have to watch for.
Okay. And then when you said like there's deformation, is there a way to distinguish deformation as a result from direct faulting or just general deformation in the area because it's so close to the plate boundary?
Well, how we talk is sort of primary and secondary deformation. So you should see primary through-going fault traces that are disrupting young landforms and young features. You may have secondary zones of kind of tilting or other kind of folding of the surface, that, as well as some discontinuous secondary deformation. Yeah, I mean, it's pretty localized. Like within the mapping area, you're getting, the main plate boundary action, aside from like what happened to the Basin Range or something.
Okay, thanks. And then pretty much, because it's kind of long, this guy, I think I went to toggle between my Google Earth application a little bit more because the photos, because they're all maybe different qualities, there's a lot of discoloration and it can be a bit distracting. So I might try to toggle between the desktop app and QGIS a lot, and then also use that to try to see any elevation to kind of give a little more indication that the features I'm seeing are there or maybe evidence of faulting. And then I also wanted to ask that, is it possible when because Google Earth has elevation data, to create a contour map from that and then maybe import it to QGIS to create a hillshade? Because I know Google Earth is the only imagery we have for this one.
I saw a tool in QGIS to create a contour map, but I tried to process it the other day and it didn't go through for me from the DTM that I had.
The question is to think about what elevation they are using. And if that was pre or post this 2004 earthquake. I think Google Earth calls Shuttle Radar Topography Mission. And I'm not sure, actually, right now I'm drawing a blank on when that was acquired or what version of it.
2000.
2000? So yeah, actually, Rachel, you can go to Google Earth. You could also go to Open Topography and get the global data there, which will let you download a geotiff of a digital elevation model, which you can then make a hillshade or a contour map or whatever secondary products you want.
Yeah, that seems like a great idea, actually, is to go to Open Topo and get, and it's the GL1, it's the 1 arcsecond. Make sure you get not the GL3, because that's 90 meters, but the GL1 is 30. And it'll be really helpful, I think, yeah, for you to kind of get a lay of the land, as it were, and it is pre-event if you're doing 2004.
Okay. And then that's pretty much it. I'm gonna finish my geomorph mapping and then take your guys' notes on that. So you said Open Topo would be the best way to do that?
Yeah, you can put a box around the area and then look for the 30-meter global data.
Okay.
But you'll find a B4 data set, and you do not want to use that one because that will be after this earthquake.
Okay, don't use B4.
Ramon will.
Yeah, see, this red thing is the B4. You don't want that, but if you just draw a box, like, select a region, draw this box, and then see, you don't want all this high resolution. You want this global data over here, and then click on this GL1, and then you can refine it. But like here, Little Mountain, and do geotiff. You can experiment, maybe get some additional hillshades, whatnot, and then put your name here and run it.
Okay.
And then you'll get various products, and then there's this one product which it's a .tar.gz, so it's a compressed archive. So uncompress it twice, and then inside there is the geotiff of your digital elevation model that's in latitude, longitude, and so you can pull it into QGIS, and you'll want to consult with Chelsea on that issue we talked about with Alana with the vertical exaggeration for making the hillshades, or project it into UTM.
So yeah, I'm happy to help. Also, if you search like QGIS hillshade from elevation or that, and or Z factor or S factor, you should get it to work. You'll either want a Z factor or an S factor, but not both.
Yeah, just to be clear for a second, what's going on is that you have like meters elevation, so it's like from 1,500 to 1,800, but then the horizontal positions are in 10 to the minus 6 degrees. It's like minus 113.00004.00005 is like how, as you're moving across the landscape. And so that huge range in the numbers, like just the orders of magnitude of the numbers, because they're in different units, kind of messes up the calculation of the hillshade in its standard mode, because it works a lot better if it's meters X, Y, and Z. So anyway, this Z factor is a correction. It's right here. So anyway, Sorry.
If you've done an arc, it's essentially the same. And then the only thing with CJ's is we did have to change the range. So if it's like 10 to the massive power, then put it down to like, just look at kind of normal numbers like -10 to 10 or -100 to 100, and then just find something that looks good and iterate from there.
Yeah.
But you should also, making hillshades from these global products is super common. So you might even be able to just type in like QGIS SRTM hillshade.
Yeah.
Okay, I'll give it a go, and then if I run into anything, I'll reach out. But thank you for the help.
All right, great. Thank you, Rachel. Lori and Jenna, who would like to go?
I can go, Chelsea.
Great.
Okay, let me share my screen. Okay. Also, there's some construction going on behind me, so if it's too loud, please let me know. So I'm doing also Parkfield, but in the 1966. So we have the historical imagery that I think Sean did for his last project. And so here's kind of an overlay of what was done. I've been looking for more topography maps, just because I think that this could be a useful resource, and it's like similar to what we did in like the very first exercise of this semester, but I haven't had much luck finding ones like an appropriate scale. They have really large ones, but I'm trying to find more high resolution maps. But so this is very different than the last mapping project I did because it's all imagery. There's no sort of DEM or even like color imagery to look at. So when Ramon was talking in the beginning about how you could just tell that subtle color difference of a way to determine some offset, I can't do that as much in here. But so what we're looking at here is that I've been trying to like just identify like where there's massive or like significant elevation differences because it is hard to tell. So here you can see that there's this, what I think is kind of like a ridge or a scarp trending across the landscape in this direction. And this kind of makes sense in part because there's a road, there's a river. So this looks like more of like a flat area that's being farmed. And then this looks like more vegetated. And so this was just a way to kind of clue me into like where we're starting to see these elevation differences in this landscape. So here's an area that I would start to look at to map a fault, but I wouldn't put fully confidence in that line yet. Also, when I go kind of south, of, like in the region, it was really helpful hearing Sean's presentation last time about like what these are, those like farming terraces. And so here it's helpful to see that again, we see this kind of line, this ridge line that's hugging this like little bit of elevation difference. Additionally, so like this seems to be more of like a farming low area. So look like this whole area to me kind of seems like a basin where there's like mountains on either side. And so that is helpful to start to pick out where this mountain front is or this ridge front. So here's like an area that I would consider looking at for more of a fault. And then I started on the very southern extent of the border area. I started mapping some of these ridges, or at least like identifying where we see these significant breaks in topography. And this would be like kind of like a scarp. And so there's two, they're a little bit offset here. And so part of my plan is just to continue moving north along this front and starting to map some of these features. But it's pretty difficult in terms of there's not a lot of data to work off of. And so then finally, this is an area that's a little bit more north, but there's this subtle color difference. And it seems like given that this is a river right here, that this is a pretty flat area that's being farmed or developed for agriculture. And then we see this ridge and then some trees. And so it seems like there's a break in topography here. And then this like subtle color difference maybe is indicative of some kind of sediment, or maybe it's just some kind of fan or a deposit of sediment that's being shaped. So I think finally, I put this image up. I realize there's not a lot of scale on these, but I've been trying to just also make sure that I'm not mapping any sort of human or like anthropogenic features in the landscape. And so I think here's a pretty clear example where here would be a pretty subtle geomorphic feature. There's no road. versus over here, we see, I think this is a road on this side of the image, but then we also see this weird vertical line here, which is some sort of artifact of human life. And so, yeah, I guess I spent a lot of this week just trying to not really map specific features, but just trying to figure out how to map them in a way that I'm not including anything that's not an actual feature. So if anyone has any suggestions about how I can more effectively map an area like this, I'm definitely open to them.
So for me, this area was super hard, but what really started to put it all together for me was mapping the drainages and seeing which direction they go. That definitely painted a better picture for me of what was actually happening. And it also started to like get used to seeing the weird changes of, you know, the images of these images, because there's a lot of weird changes. So, but I don't know, I think that's a good place to start.
Okay, yeah, the other thing, there's a drainage somewhere in here that I picked out that seemed to be a little bit offset, and I don't know what happened. Oh, right here. So another reason I mapped this area is because there's this drainage coming in here that seems to do this kind of interesting bend connecting to this main river system. So I started looking at more of like because there's like the main through flowing like north-south-ish river system, and then there's drainages coming down. And so I was trying to look here for offsets. But yeah, that's a really good place to start.
So you look at like this image specifically that you have up, and you can like, let me maybe try and annotate something here really quick. So like, I don't know, like mapping like these drainages and then seeing kind of like where they go. Seems like, I think I remember this area and almost all of them started like going this direction once they got to the end. And so that's like something that you can key in on, or I don't know. Look at the smaller drainages and then, you know, not just the big river systems.
Okay, great, thanks. That's really helpful.
Yeah, a couple of thoughts. I totally agree with the looking at the drainage network, and especially comparing the behavior of the smaller drainages, like the ones on the side of this hill right here, versus the big ones. So there's like the big Chelam Creek, which is on the left there, is a broad kind of braid plain with some pretty young terraces associated with it. So make sure, like I would kind of almost treat them separately, like just map the main swath of the fluvial network. That's the aggradational part of Chelam Creek and some of these other larger ones, and look at them in one way, and then look at the kind of potential for sort of more deranged drainage in these smaller ones. And I wouldn't feel too, you know, you kind of, I think you sort of feel hampered somehow by these data, but you know, it's a really interesting opportunity. It's the classic way that so much of the world has been mapped until color aerial photography, which is only, you know, the last 25 years. But for the preceding 100, everybody was looking at black and white aerial photography. So, you know, the power of the black and white aerial photography is it can have pretty high resolution, and it has pretty broad sort of sensitivity, even though it's a single band of color. So I would, you know, just really read into everything. Like here you can see, okay, this ridge top, you know, this is the top of the ridge, obviously, but you can tell the dark side is sort of the north facing slope, which is indicated both by the darker tone as well as there's a bit more veg on those north facing slopes, these bushes. And so you can, you know, just spend some time looking at those light and darks. If you go to that last one you had, so here, well, just one comment here is I agree with that there's something interesting where you have the black lines, but down here, well, everywhere, but make sure you look across the whole zone. So be pretty systematic in terms of your coverage, because you could find interesting things in any part of the width. And then if you go to the last one, yeah, so here, you know, I do, so the whole thing about the agriculture is that they pull these big, huge harrows behind the tractors, so they can only get up so high on the slopes, and so it's kind of like right where the tractor can go. And so a lot of times it's almost indicating a contour, especially up in here is probably as high as a tractor could go. And then this is probably, this is, one rancher, and then this is the other rancher, and they have totally different philosophies of land use. So, but the other thing is even here, this is a ridge and this is a ridge. And so you can see the darker north facing sides of them. And then you see how the drainage is sort of focused through there. And so that already starts to tell me there's something interesting with this little line of discontinuous ridges that might be interesting. So maybe you saw that already, but I would, don't be shy to try to deal with some of the morpho mapping in that sense, and just kind of where the ridges and some of the little ones, and looking for, like we talked before, any single indicator of faulting or like unusual topography is one thing, but you have to have an ensemble. You have to have a group of them that indicates that you're in the shear zone, and it's not just some anomalous or random thing. So be thoughtful about accumulating indicators along strike of a suspected zone.
Okay, great.
So one more thing, I didn't do this, but I've done it in the past on other images like this. That's pretty useful, is the stereo imagery. So these are stereo pairs, so you can actually see the 3D of it if you have some of those special glasses, which you might be able to get. So
Okay, great.
I totally agree with that. You'll have to make sure you find the ungeoreferenced ones, because the georeferencing sort of distorts the distortion that your brain wants for the parallax. So try to look around. But yeah, the stereo pairs, if you have them, will totally take you there in 3D.
It might work with these because they're not so well georeferencing, like couldn't actually get them fully on top of each other.
Yeah, you'll notice that too. But there's a lot more like images in the ungeoreferenced folder than there are on this, that have been georeferenced. So they're all there. So.
Okay, great.
Yeah, I was gonna say, I actually wasn't able to get the northernmost georeferenced because there are just no features, no roads or anything that kind of seem unchanged. So don't worry about that top part of the zone.
Yeah, that's what I was trying to find a topography map for, but then I will not know.
Yeah, so the topography also, oh, sorry.
Go ahead, Sean, go ahead.
Yeah, the topography, I spent like almost 2 hours trying to find other topography maps, and I was not successful. But I mean, who knows, you might be, so.
Well, I haven't, so maybe they just don't exist.
If you find those, either I can georeference them, or actually I just georeference them to the Bing roads. So okay. If you wanted to do that for a couple, then there's no issue looking at the Bing road map. And it's pretty fast because you're just like doing corners of roads.
Yeah.
All right, thank you, Lori. Jenna?
Good morning.
Morning.
Okay. All right, is that working? All good?
Yes, perfect.
Okay, cool. So I had the Monte Cristo earthquake in Nevada, and we decided to map directly onto the Google imagery base map, as it was the same. And so this is from 7/16/2016. So it's just a nice image of what I'm working with. Like John said last Tuesday, whatever, I'm not even sure what day it is. This area is pretty overwhelming to look at. So I kind of just went ahead and, oh, there we go. I just started kind of going for it. And so I originally started by identifying some ridges down here. And then going with the drainages and just trying to follow through, looking for any offsets or any indicators, just trying to get a sense of what's going on in this area. And so I've been using Google Earth a lot as well to help with the elevation. And so you can see I've picked out some sag ponds as well over here and some triangular facets. So this was one of the areas I started in. There's a lot going on, but originally I immediately saw this kind of triangular feature, and then I need to map some more of the drainages, kind of connect them. And then similarly, this was the other area I started in. And I think this is more of like an alluvial triangular facet. So there's just a lot of, different things I still need to differentiate on as I go forward with mapping. There we go. Also, I've noticed that I tend to get stuck in a lot of these like weird Nevada like dirt roads that kind of are, they're just kind of spread through the whole map. So that when I'm up close mapping, maybe at like a 1 to 5,000 scale, those tend to blend in with the alluvial paths and whatnot. So that's just something I need to be aware of. But yeah, I don't really have that much to say as I'm just kind of chugging through this and trying to figure out what's happening. So.
Have you started to get a sense of where the faults might be?
Kinda, not really. I have an idea, but it's just, there's a lot going on. I suspect one down here, I could kind of see maybe a little bit of a trace, sorry, as I was mapping the drainages, but other than that, I'm not too sure just yet.
One thing I'll add then is, this is a great one. It's pretty challenging, and I like your work on the drainage network. But here, I really want to encourage you to look at those different aged fan surfaces and map them out. So these dark and light zones, like this you see like right in front of us is this kind of whoops.
Oh, sorry, I just changed it so we wouldn't have to look at all the stuff already true.
Yeah, so see that fan right there? And then there's this one here. So those dark zones are, indicating different ages of fan surface, alluvial fans. And, the darkest ones are pretty old. There can be even older ones that are sort of eroded into, but they have all these desert pavements that make those super smooth, dark surfaces. And so I would spend some time on them and look for, you sort of get a sense what you're expecting is like in this zone here where I've drawn the purple or whatever color that is, that we have this sort of sculpting of these older surfaces by younger channels, right? So they're sort of shaped in this elongate way. But if you zoom in, do you start to see that there's some sort of weirdness that's kind of inside them that you can't explain by just progressive incision? So I think that's the other strategy beyond the drainage network that you're going after. So there would be that, and the darkness is partially controlled by the development of the desert pavements, but it's also controlled by the source material. So like these surfaces over here on the far right are dark because they're eroding some dark rock, but there's still some flat, flat surfaces that are representing those zones of former fan surface that are now stable as the rest of the landscape cut in. So that might be another strategy because they're fairly straightforward, and you can kind of break into a couple of different classes based on their geomorphic position and degree of pavement development.
Okay, yeah, that sounds great. I'll definitely get into that as I go forward.
Don't forget, you can also take the same SRTM DEM that we were discussing with Rachel?
I did that. I downloaded that and applied it and everything, but it didn't really help much at all.
Okay.
So
I mean, at least you know which is high, which is low. You know, don't expect a lot from it, but it's like opening a second eye. At least you know what the relative elevations are, and because you want to have a little bit of a sense of which way is material flowing in this system, where's down, where's up, and are there some kind of weird ridges,
okay, cool.
Any other comments for Jenna? All right, thank you. So that is everyone. Thank you, everyone. Really appreciate the enthusiasm. It looks like everyone is making good progress on their mapping. So that is excellent. So for next week, keep up. We'll have, I think on Tuesday, the plan is another career discussion with Rich and Chris. I will confirm with them. And then on Thursday, we'll have the group that presented yesterday will make their next presentation. And then just keep in mind that the week after is Thanksgiving. So the group that went today will present like in 10 days on that Tuesday. And then obviously we will not have class on Thanksgiving. Are there any questions or comments from the class before we finish?
Our final presentations, they're on the 1st and the 3rd, is that right?
Yes, and I'll send out, plan is before the next class, I'll send out a instruction form or kind of outline and then grading rubric. But the plan is generally that you'll make a 10-minute presentation. Your choice can either be on one of your mapping projects or some comparing and contrasting of the two areas, but details will come.
Perfect. I was just wondering if I could make a request to go on the 1st rather than the 3rd, because I'll probably be in an airport on the 3rd.
Yes, I think that's fine. If anyone else has specific requests of a day, let me know.
Thanks.
And then just keep in mind that Friday, December 4th, at least at ASU, is a very hard deadline for when all coursework must be completed and turned in. So the mapping reports for the second project will be due on that Friday.
Yeah, just good job, guys. You're making progress, but keep it up. I think everyone's sort of still in that stage of just kind of poking around, but maybe try to push yourselves, get that seat belt yourself in the seat, and get going for a couple hours and see what you can do, and keep that steady progress. But it's looking good. I like I said when I was talking on Tuesday, I really appreciate your increasing confidence and sort of comfort at speaking about this work. It's really nice to see.
All right, great. We can bring class to an end a few minutes early. And if people have any remaining questions, I'm happy to stay on.